how you all doing? So in today's tutorial, we're going to understand the concepts of unsupervised machine learning. So in the last tutorial, we understood what supervised machine learning was. That is, we feed in some data first, and then we feed in some new data, and based on the old observations, the model learns on what to do with the new data. But now we are not giving in any old data or new data. In fact, we don't even have anything to predict. So we're just going to give a certain data set, and we're trying to find patterns within the data. So this method is called clustering, and the two popular algorithms are the k-means clustering and the hierarchical clustering. So in this video, we're going to focus more on the k-means clustering. So here are the steps involved: importing the necessary libraries, importing the data set, then combining various features to make the data set simpler. I can just go through this for a second, and I'll just take you through the entire process. So here we go. So yeah, on importing the necessary libraries, again, just like the last video, we're importing NumPy, Pandas, and Matplotlib. Okay, and as you can see, I'll just repeat again. NumPy is used for handling various arrays. Pandas is used for handling various CSV files and rows and columns and all that. And Matplotlib is to show various custom plots and just various other plots you can see. So now we're just importing a CSV file. So this iris data set, you can find this iris data set in the machine learning repository from UC Irvine. So you can just type UCI machine learning repository and you'll get this data set. But however, I'll also be leaving my GitHub link in the description below, so you can have a look at that. And I can just see the summary of my data. So I can see there are 5 columns, one with ID. I'm sorry, there's 6 columns, including ID. Then there's sepal length cm, sepal width in centimeters, petal length in centimeters, and petal width in centimeters, and there's a species. So given this various data, we are also given what the given species is. So now we're trying to simplify this data. So I'm just going to take sepal area, because instead of 4 columns, I can just make it about 3. Instead of 6 columns, I can just make it 3 or 4 columns. So sepal area, I'm just multiplying sepal length and sepal width. And now I have a column sepal area here. And now I'm just going to drop sepal length and sepal width. And this is my data set after that. Moving on. So I can do the same thing with petal. I've dropped ID because it's not going to really contribute to our model. And yeah, so now I'm dropping petal length and petal width and converting that to petal area by just multiplying. So this is a rough approximation that a petal is a rectangle. I know it's pretty ridiculous if you think about it, but it's just a simple approximation to get various size, to get a size of a particular flower. So moving on. So yeah, this is my final data set right now. I have the species, the sepal area, and the petal area. So from 6 columns, I just made it 3 columns. So now we're taking the necessary features that we need for clustering. So all we need is the sepal area and the petal area. And with this, we're going to use predict what species the particular flower is. So as you can see, I've just made this array, and in this we don't need an independent variable because there is no independent variable because we're not trying to predict anything. We're just trying to group the data sets and find patterns within them. So here we're finding the optimal number of clusters. So optimal number of clusters in the sense when we have a lot of data points just scattered across a plot, we're trying to map everything and just separate the things out. So if you want to separate, so let's say cats, dogs, and rats. So the ideal number of clusters is 3 because there are 3 groups of animals. Whereas if you're trying lions and tigers, the optimal number of clusters is 2 because you're only doing 2 animals. So now let's just have a look at this code cell. So from SkyCircler.cluster, I'm importing the k-means method. And WCSS here means within cluster sum of squares. It is a total distance from the potential centroid to the cluster. So every cluster will have a centroid. Okay, a centroid is the same thing what it means geometrically within all the points within the given region. So yeah, this WCSS will just contain an array and it's used to separate out the various points. So now I'm just taking a random range from 1 to 11 and I'm just going to loop through the whole thing. So now here k means plus plus. So what this k means plus plus means, it just is used to avoid the randomization trap. So normally we get some random initialization and this just helps us avoid that. So that we don't get so again, so coming to the examples of dogs, cats, and rats. So if some cats look like, so if you're doing 4-legged animals versus, if you're doing like taller animals or shorter animals, they will look cats and dogs in one cluster and rats in another cluster. We're just trying to eliminate this randomization. And random state, we can just give any number here. Apparently, I read somewhere that the perfect the number for random shade is 42. I don't know why that is, but hey, we can try it on different numbers. I just kept it at 42. So now trying to fit the model, and yeah, we're just trying to make a plot here. And yeah, k means dot inertia. I'm just adding uh, each and every row, each and every iteration to WCSS, that is within cluster sum of squares. And now here I have. So yeah, so this elbow method is helping us to find the optimal number of clusters before we can plot our k-means clustering. So as you can see, this bends the most over here. So wherever this cluster bends, where this line bends the most, that's where we have to find our optimal number of clusters. So yeah, we can see it bends around 3. So we have a total of 3 clusters. So that's why I put n is equal to 3 clusters. And now I'm going to make my cluster, and boom, we have 3 various classifications: 2, 0, and 1. So now let's assign this 2, 1, and 0 to what we know. So all right, this is how I'm plotting my k-means clustering algorithm. So this is how I'm just going to visualize it. So so from this 210, I've realized the types of flowers that are available. So the 3 types are Iris virginica, Iris versicolor, and Iris setosa. So I'm just mapping them to a green color, blue color, and red color. And if you see the plot, we can see the green part is Iris virginica, the blue part is Iris versinica, and sorry, Iris versicolor, and the yellow part is the Iris setosa. So now if you just see the data, so we see the set data, we have only 3. So that means our optimal number of clusters, right? Since we have only 3 types of flowers. So now let's just have a look. So we see the mean sepal area is around 17.2 for Iris setosa, which is right. So the centroid's around here, 17.5, 17.2. So and the mean petal area is 0.36. So yeah, it is between 0 and 1, and it's closer to 0, so it's 0.36. Now for Iris versicolor, the mean sepal area is 16.52. So let's have a look. 16.52, and yeah, so the centroid is right over here, and the mean petal area is around 5 point I'm sorry, yeah, 5.72. So as you can see, yeah, the mean petal area is around, it's slightly closer to 6. So it doesn't matter. And we can see the same thing for Iris versicolor as 16.5 as sepal area. Sorry. Yeah, I'm sorry, 19.68 as sepal area. And petal area, we can see it as 11.29. And yeah, so this is how we predicted our k-means clustering algorithm. We haven't note that we haven't given the previous values of whether the flower is Iris setosa, Iris versicolor, or Iris virginica. So we have just given a bunch of data and we've separated, and from the previous data I have manually converted this. So that's it. I think that's it. In summary, we have 3 types of clusters, and that's our optimal number of clusters. So thank you all for watching, and have a nice day.